Hello everyone. So we have 3 people. Henrik, Tech, and Taurus. And Sniff is also there. He joined, at least. He joined bitluni and TTS. Okay, so today, boring stream. We need to... You're still here from last week. Oh, why? Hello, 40K. Hello, Dave, Odessa. And Brian is also here. Hello, Brian. I can't hear anything. Oh, wait, I need to trigger it again. I was too early with the trigger before the stream started. Okay, let's reset and start. Here we go. Now we playing. Where are the sounds? I can't hear. Hello, Mr. Johnny. I can hear now. Yeah. Okay. Should we start right away? So today's noms are strawberries and cherries. That's everything. I hope you're doing fine. We have almost July. It's a good summer so far. Fun for the whole family. Hello, Arduino Zone. Okay. So no pink LEDs in this stream. I'm so sorry. Unless some wonders are happening and we are done. Yes. I hope I don't get COVID. Many plans next weekend. But it should be enough time to recover. Yeah, there is so much chaos in the background. Okay, so state boycott. Yeah, I will test. I don't endanger other people's. Imagine Dragons album. What is that? Do I know this? Is this music, or is this Dungeons and Dragons? Okay. It's a real band. Oh my. Okay, look at that. I smashed my screen this weekend, and I had to replace it. And the display, the new display sticker sucks really, and I had to use Scotch tape. Alright, we need camera. We need this camera to show the oscilloscope. The replacement, yeah, it's a screen from eBay. It has a little bit like more noise when it's dark, but yeah, that's. Oh, I was looking for a new phone, but all the new phones don't have headphone jacks anymore, so that's sad. Oh, Stranger Things? What? Oh yeah, I watched also the first 7 episodes, and I can't wait to. It really feels like the new season of Stranger Things totally feels like Akira. The story is so similar with like the kids and the kids with superpowers in the research facility, and there is one secret kid. Oh yeah, I don't spoil. Totally Akira story, and I wasn't the only one who had this feeling, because I googled it, and there were many other people who asked for that. If the IKEA, no, Akira, that's like an anime from the 80s. So if you haven't watched that, do so. Okay, we need some. Where is the power supply for this thingy? Here. Okay. My chaos here. Okay. So, now it's a power supply supplier. Or it's a power supplier? Good point. Who knows? Okay. So let's take a look. I give you a short recap. Okay. Okay, here we go. Okay, short recap. What I've been working on. So I have some ADC boards like this one here. Oh. Yeah, okay, here we go. It has 8 ADCs up to 2 or 3 megasamples per second. And I want to use I2S to read them. I did manual readout with like 340 kilosamples per second, but this is like the maximum that is doable. And now I try to configure stuff. Hello, Tobias. I try to configure stuff to I try to configure like the control signals as like a clock and a word chip select of a specific type to read in the 12 bits. And I try to generate this with LED control, but this isn't supported in high speed on the S2 that I'm using. So this is the ESP32 S2. It's a like cheaper version, 1 core only of the ESP32, and but it has internal USB, so that's nice. So basically that wouldn't work, and we were talking about using I2S output and input at the same time. But I tried something else in the meantime. There is another peripheral. So today will be boring coding time. Where's my desktop? Wait. Oh, no, this. Okay. Let me check. Here we go. Boom. Okay, so we have several peripherals that we can try, and there is, yes, hacker mode. Oh, I don't have the cup. I only have this cup here. The hacker mode cup isn't here. So I2S, there is only one I2S controller on the S2, but it supports read and write at the same time. You have only, I think, one clock that you can. So this peripheral doesn't work. It's not fast enough. It only supports low mode on S2. But look at this one here, remote control peripheral. And this is the, how do I move this over here? So the remote control peripheral looks quite interesting because you can run it from the system clock. So this one here, no wait, AVP, I think this is 80 megahertz. And you can basically provide it with a bit pattern to be sent to any pin you like. So this is carrier. Okay, here is the, we don't use the carrier because you can basically generate a carrier frequency and modulate what you output here. But basically what this peripheral, it's quite cool. I was able to, so I could set it to 80 megahertz. And since I'm writing one bit up, one bit down, and one bit up, and so on, I can generate a 40 megahertz clock. I will show you the result. And you have multiple, I think 4 controllers. So you can use them at the same time. And these controllers have their own peripheral RAM. So you can fill in the bit patterns in here and basically bit bang with the controllers. And you can even synchronize the controllers. I didn't do that yet, synchronize the controllers. But basically what it looks like is you have like this 32 bits, and one bit is basically the level of the bit and the period in cycles. So, and that's basically like a list, and whenever you have a period of 0 cycles, it means this is end of list, and it will basically repeat. I think you can configure if it repeats or not. Yeah, you can configure the loop count. So let me show the result of that. I have a project for that. And that project, where is it? Is it opening? Is it loading? Is it doing anything? Yeah, okay, here we go. Oops. Okay. Ah! Okay, here we go. So, all my other stuff disappeared, vanished. Okay, here we go. Okay, so these are the lists. This is basically one for one clock cycle. No, yeah, this is the cycle, I think. And yeah, this is 1. And then 1 cycle, 0. And then 0 cycles, 1. And it will basically, this will output, this list will output a 40 megahertz signal. And the second list is basically 8 cycles 1, 24 cycles 0, which is the pattern that we need to read in 12 bits with the chip select. This is how the configurations look like. So there are some structures. This is basically copy paste from another thing. You can completely forget this. If you enable loop, it will basically cycle. So you only have to write the items here. So configure the, wait. Yeah. Configure the channel, wait. Here we go. The channel 0 and 1 in this case. And we install the driver and basically write the items and leave it like that. So this is init and basically does nothing. It's idle. So it doesn't take any resources on the bus, like the memory bus, which is great because this remote controller thingy has own memory, and any CPU resources. So basically we can trigger everything. Hello, Swift. Basically we can use this as a trigger signal. Let me select the source B2. Here we go. Uh-oh, wait. I killed it. No, what? Wait. Okay, let's restart. I need to re-upload. Okay. Count. Why is TTS die? Here we go. Okay, here we go. Something's wrong. Wait. That worked last time I tried. Why does it reset? Oh no. Something's broken here. Peeps, something's broken. It worked. What did I change? It's restarting. Uh-oh. What did I do? What did I do? I have more than 2, I think, but I mean, this sketch worked before. Something's off right now. I don't know what. Did I change anything? Maybe I changed something and now it doesn't work. Oh man. Nope. I mean, I get a clock acquire. Wait. Oh, that's cool. What is measuring? Okay, you can see. I will activate. Okay, the problem currently is that. Yes, I did. Somehow it resets, and I don't know why. There is something. I don't know what's happening right now. Huh? I didn't change anything, did I? Okay, let me not disable the watchdog timer. I don't think I digital write. I have no clue what's happening right now. Okay, it's uploading again. Reset. What's happening? I mean, it shows 40 megahertz for a second, and then reboots or what? D flash mode. I have no clue what's happening here. Yes. Yeah, that's what I'm trying. Yeah, I will do a new sketch and upload this to get a clean slate. Hello, Adam. Let me upload an empty sketch. Thank you. It shouldn't reset all the time. Okay, that worked. Let me keep the pin mode. I don't know what I did to break it. This isn't used. I mean, that should be anything that I do with this RMT shouldn't affect the main CPU. What? Okay, let me try only write items this here. Yeah, it's the S2. Let's try. Let's. Okay, still resetting. Still resetting. Okay, let's not write anything. Okay, this is not resetting. I'm confused now. Oh yeah. Here it is. Okay, so this is resetting. Is it? Remote control peripheral. I need to check if something is out of specs here. Let's check the docs. Oh, they changed a lot in the master right now. The latest stable. Maybe it's not so stable after all. Okay, let's assume it's only one item. So let's assume just one. Maybe that might be the issue. Doesn't like it. I don't know. Yeah, it's still resetting. Nope. Still some strange things happening. Oh no. Yeah, can you see the lower thing? Okay, what we can try is using this instead of that one. Maybe this is like faulty. Ah. core? What's with the core? The core is okay. Ah. I can see anything here. This is not how I imagined this stream. I have no clue what changed since I used it with this code. What? What's the matter, Tech? Oh, oh no. Sorry. Yikes. Yes. Ah. Okay. I have a link, invitation link. Try that. Okay. Let me turn. You reset everything. No. Turning off and on again didn't help. Okay, okay. That doesn't work. I have no clue why. Maybe let me check loop count. Let's start with 1 RMT. I wanted to fix I2S, not RMT today. Oh, interesting. Loop count might be the issue. Okay, now it's not restarting anymore. Configure the second channel. Is there maybe some kind of short or something on the pin? Could be also the issue. Imagine that. Nope. I had this loop count. Interesting. Okay. So Okay, now let's fix 2 again, because okay, here we go. Seems to be buggy, but now we are... How do I... Okay, you can see it's... How do I do this? Fine. Is this the trigger or what? Display. How do I increase the acquire? Digitizer. Here we go. Okay, here we go. This is this is what I wanted to show you. Now I don't change the code anymore. Look at this. This is 40 megahertz. It shows, oh, yeah. So this is 40 megahertz, and this is the chip select. Now it should be working. Okay. I don't change anything about this code anymore. This is RMT, that works. And we could basically use RMT and I2S in slave mode, camera slave mode. The best part is about camera, now the dirty tricks, dirty tricks. So imagine if we use, let me get this here. Wait. Okay. Okay. Okay, we have I2S as camera. Oh, you can't read. Boop. I2S as camera slave receiving mode. So it has VSync. Wait. Can we see anything? Wait, register? No. This is not the stuff. Okay, so camera has additional control, which is like VSync, HSync, href, enable, which we can use basically to maybe mask out and not record we can use basically this signal to only record, to only record the part where the bits are valid. So this could be used by the camera mode, and we can use it in slave, and basically with the GPIO matrix. So interesting stuff. I don't know if anyone tried it before. So the GPIO matrix if we have the output here, the remote control output, it basically sends it here to the pad output buffer, and then maybe we can read it back with the GPIO matrix for I2S. How about that? Do you think that works? Can we write to a pad and then read it back in with the GPIO matrix. We use it like as output and route it to a different signal. So if we use like remote control, which doesn't take any bandwidth on the memory bus, since we have 80 since we have 80 megabytes memory bus bandwidth, it's stated in the datasheet. I posted a small screenshot. Where is it? Like 80 megabytes per second. Okay, here we go. So a loopback? What do you mean with loopback? Like a wire between two pads, or just configured that way? I'm not sure how that works, but it could be interesting if I can read back the signal there. And okay, so if we would use like the Rx and Tx of I2S at the same time, we would still have to send this shape here, through the Tx I2S, which would take memory bandwidth, since we use the DMA to push in the bytes to I2S, while we are trying to read the bytes from I2S as well. So we basically clock the bus with a repeating signal, which we can basically generate with the remote control. And that doesn't take anything from the bus. So generating this signal is passive, and we get 40 megahertz, and we get our enable and whatnot. So next thing is to configure I2S correctly to read anything. So what I started to do is to configure I2S. I have like my VGA library works also with I2S parallel mode, and I try to use that. It would crash. We have a boot loop. That's implementation for ESP32, not the S2. And let me show what I did here. Here is my Sarsaparilla. What is Sarsaparilla? Okay, so this is my old implementation for I2S. Some registers are a little bit different. Yeah, some registers are a little bit different, but most of the registers are quite similar. There are not many differences, but I don't know why it would like crash. So it's hard to like take huge code base, start and see it's in a boot loop, and then try to figure out what's broken there. Okay, so I tried to take the data sheet. Where's the data sheet again? Here is the data sheet. I tried to configure LCD, features, here we go. Not datasheet, in the technical reference. Transmitting mode, transmitting data. TTS worky. Ah, you are able to join. Many texts that I didn't read. TX mode, receiving data, blah, blah, blah. Blah, blah, Mr. Freeman. LCD master transmitting mode. Okay, so I want to try that, which is basically words select is the new clock, because you always push a complete word in one cycle here. And you have the data pins, which are basically counted down from wow, Adam, congratulations. Okay, so we have, let me move that away again. So we have a complete list of things to do. And I did all these things and it crashes. So either my buffer is broken, or something else is broken in that. But this doesn't boot loop anymore. Okay, I can show the code. So this is the, let me close the other one for now, because we don't want to break it by accident again. So no worries. So write block parallel master, okay? And then I put in the comment here and did exactly what they said. Clock enable, so configure the clock, then configure the pins, then I'm not using the Arduino Labs here. This is code, this is IDF code. So basically you have access to the hardware abstraction layer, and I'm writing the registers directly. I'm not using any libraries here. So this is like almost pure hardware layer. Only something like that here, but this is like proven to work. Otherwise, nothing would work in that. So this is basically like I copied the text from the technical reference and implemented this, and it wouldn't work. Maybe I try to yeah, I try to configure a ring buffer. So 2 buffers are 1000 bytes, and they would basically point to each other. Then configure the pins and write parallel and so on. It should basically loop indefinitely, but it doesn't, because there is a flag which says what's happening right now. Where is it? This flag here, state idle, and it's basically wait. Was it 0 or was it 1? Maybe it worked. Let me check again. Okay, this is another implementation. That I stolen from the interwebs. I2S and what's I think, yeah, it's TX active. It should be just outputting 0 all the time. Oh, there is no delay. Oops. Huh? Oh. what's that? I forked? And no, I just copied it. Didn't fork. I'm too stupid to fork stuff. It was MIT license, so it's okay. Oh yeah, he wanted to see the output. Yeah. TX active is basically 0. So it doesn't crash, but it doesn't work either. So it doesn't, at least, okay. Maybe let's leave the descriptor like that. Don't do any next stuff in it, and then basically try to write here. Wait, we need to define this here outside. Okay, here we. Okay, let's try again. I eat some cherries meanwhile. Okay, maybe it's not looping, but to-do list. Okay, let's do to-do list today. I can. Okay, so obviously there is an error. Otherwise, we would not get instantly 0 output here. Okay, let's do to-do list. Building phase. What is this? Okay. Yeah, that was. But we can do it. Remote control, RMT, signal. So, there is nothing with the, there is nothing with the LED wall. There is nothing there. Okay. Write I2S block. Okay. Hello. Then read. Oh, write parallel I2S block. Thank you. What? Okay, here we go. Then block master or read slave. And that's basically it. Oh, no. And then use sync signals. And maybe okay, test with ultrasonic. Okay. So maybe I should check if it's what's the matter. Okay, so this is like this implementation, but I found some other dude's implementation that works. It was like in the forums, ESP forums, which is basically if you yeah, we don't need that and that, which basically drops like data bits to I2S. Oh, you can see here, there's something happening on the clock signal. So I assume we have also output on the data pins. Let's test that. We just need we can use okay, let me get the trigger source S3. Oh yeah, there is some data. Okay. Okay, it does something. I don't know. Maybe it's only the first byte. So let me get. Shouldn't it initialize the complete array with that data here? Oh yeah, there is some more. No, that's like. Oh no, that's always like the first byte or something. What is this? Okay, here you go. What did I try? Oh yeah, okay, here we go. This is like some data for you. Yeah, this is like the first bit. So if what? No, there is no ping pong wall anymore. The ping pong wall. Let's not talk about ping pong wall anymore. Okay, here we go. Why? How do I synchronize that properly? I only want the first trigger edge, trigger. Pulse width and lower and foo. Ah! Okay, let me. Now I will break everything with the auto calibrate. Here we go. Yeah, no, I broke everything. I don't need that. What is that? Yeah, I need bandwidth limit. Do I need this? Bandwidth limit. Here we go, clean one. Why is this one so shaky? Okay, trigger, source. Oh yeah, that's what's nice. Wait, here we go. Yeah, something's happening there. Something's happening there. Definitively. So this is the data, this is the clock, the word. Oh yeah, you can see it's so small. Let me scale that up for you. Back. Okay, back. Now I need to check what did I wrong so my implementation doesn't work. Let's start with the buffer. Owner and EOF are only, so my descriptor is owner EOF, everything else is 0. This is the same. Okay, set pin config clock. So this is like interrupt, but I cleared every interrupt. I don't want interrupts. DMA start. Okay, so this is the start. Outlink start 1 and TX start. Descriptor enable. And my implementation has TX start. Okay, let's use this again. And this again. Clock, active word select, clock. Okay, great. How did I configure it? Clock, okay, yeah. So we should be working with this again. Okay, let me write it again. Oh, we need a delay at least. Hello, Aaron. So the title of the stream triggered you? Okay, doesn't work. Let me write again. Yeah, it's really busy on the port. Okay. Okay, this is what I thought. It's 0, 0, 0, 0, whatever. So let's go step by step what this implementation does. So outlink start. Descriptor enable start, outlink start, tx start. I might have not this part here, outlink. What? Outlink, outlink address, outlink start. Oh wait, I didn't turn on the DMA. I didn't turn it on. No. Something's happening. Something's happening. Oh, it's restarting. Okay. I think we break it. We break it somehow. I don't know. I don't know what happens. I see like there is some swizzle. Yes. At least we should see the clock somehow. Okay, let me see. I don't know what's happening. It's a boot loop again. Not sure if I can catch the signal though. Yeah, this is difficult with the built-in USB. If it's boot looping, the built-in CDC doesn't work. Let me check. Okay, wait, we are not boot looping. There is an output. Wait. I hope you can see what's happening. Huh? It stops again. Huh? If I don't delay, it doesn't restart again. It does something. We get an output, but somehow... Okay, here we go. There is something. Wait. Acquire, digitizer. Okay. Wait, this is microseconds. This is now the clock. Bandwidth limit. 20 megahertz. Oh no. Is this the highest we can get? Okay, so we have an... yeah. So we are only able to record with like I use 20 megahertz. That's not, I'm not satisfied. Okay, at least it works now. Can we try to use the ring buffer? Like that and that. Okay, let's try the ring buffer. If we can get an indefinite loop, that would be cool. No, 80 megahertz is the clock, but you can generate an... There are some dividers. Oh, yes, baby. Okay. So the loop works. Yeah, infinite loop. Okay. I need to save this. This will be like... That's an ADC test. This is like to S. Loop. Okay, I call this, I need to store each working code. So I renamed this project to loop and will basically reload it and try again. Yes, I had to, because the specs, I mean, we can try to go out of specs again. This is the highest configuration that I was able to achieve. Let me try if we can change the clock here. That would be out of specs. Let's see if we can get a higher clock rate. Nope. Wait. This isn't the same. This isn't both 20 megahertz. Yeah, it's 40 megahertz. But huh? Yeah. Wait. What is this? Is like one division is 25 nanoseconds. That's 40 megahertz. Why does it? Okay, bandwidth limit. Do I need to like? Oh wait, acquire. Ah. Yeah, that doesn't matter. I can change the driver level. Turn off. Yeah, I try. It is off for this one, at least. This one still has bandwidth limiter. Wait. There might be some kind of reflections or whatever. Okay, let me check if I can change the driver Maybe that's skewing the waveform. Let me check if I can change drive capabilities. Okay, so we can change the drive. Wait. This is not my code. This is my code. Okay, so we can set matrix outputs. We can do that. Pin cap 3. I have no clue. Probably we need to include a new. It's not declared. Okay. This will be mux GPIO maybe. Okay. Let me check where this is defined. No, I try to read, but I need to configure it first. It's harder to configure reading the signal. Okay, I will need this at some point to drive the ultrasound, okay? But reading as slave or reading as master is way more difficult if you're not able to check if the signal works or not. Put it high. Wait. Okay. Strength, drive cap, strongest signal, weak signal. Do we want a weak signal or a strong signal? Wait, does the S2 even have that? Yeah, it has strong. Driver GPIO, that should be there. Driver GPIO. Let's try again. What's not declared in the scope? What? Huh? Okay, let me check the stable if this wasn't implemented in the. No, it's there. No. Huh. What? Where? What is the define? Let me find that. GitHub. There must be some kind of server, UDP server. No, not S2. RTC I/O. Okay. So yeah, something like that. Okay, so we need RTC. Where is this? GPIO SOC. Peripheral control. Where's the RTC? Did I include it somewhere here? Yeah. Driver RTC I/O. This is the one that we need. I think we don't even need that one here. Oh, you can't see anything. Sorry. Yeah, that's strong. Let's do weak. Do we want a strong signal or a weak signal? What do we want? It looks like 40 megahertz. Okay, we can try to use a resistor. Let's try a resistor. Let's try a 10K resistor to ground and measure it there, okay? Or what's yeah, no difference in that. Which one is it? This one. Okay. So let me get yeah. That doesn't do anything. I need a lower one. 1000 ohms. 1K, okay? No. Okay, so this is the best clock shape that I get. Should we try a higher speed with like even higher, better clock? I mean, there is like, let me check configure clock. What's the clock source? RX clock source. I think we have different options with that one, so let me get PLL and APLL. So why does it? No, it's like, it's more 40, but it doesn't show as 40. Let me check. Analyze. Wait, where is this? Trigger. Wait. Oops. Analyze. Frequency. Yeah, something like that. No? Where is it? What do we do here? What is this analyze? What does it do? Where is my spectrum? I want to see the spectrum. FFT there, okay. Not source is 2, 3. Span is 100. Center is at 80 megahertz. Wait, how do I shift that? How do I shift that? Oops. I want to shift. Wait. I need to shift. No, this isn't working. How do I shift that window here? Okay, center is span is 400 megahertz? No. Oh, you mean here? No. Okay. I do the span is, let's do 100 megahertz, and the center is 40 now. Okay. Yes, look at that. That's certainly center for 40 megahertz. So our clock signal, I don't know how to move this, the display. Wait. Display normal, average, max hold, min hold, no. I have no clue how to shift this. Okay, can you see the 40 megahertz? This is like there is no doubt that this is 40 megahertz, and the other signal should be like 20. Okay, here we go. This 20 is just at the half. Okay, good enough. Okay, no need that. Let's put this on. This is our clock. Look at this. When I scale it down, it shows even 40 megahertz. If I make it small. Okay, the problem I see right now is that the writing that this is out of specs, I think, the clocks. Okay, let me check. PLL is 160. How is that 160? We have a division here. number n needs to be 2. Otherwise it's 265. Is this for... Okay. So master clock, 160 megahertz. Analog serial clock, module is... Okay. So we have 160 divided by 2, so it's 80, and then divided by 2, it should be 40, because back out diff back out MO. MO is between, must not be configured as 1. Okay? This is the master transmitting mode, serial clock. Okay, this is master transmitting serial clock. This is in, okay. Cannot be configured as 1. Using functional divider may bring clock jitter in case cannot be generated from PLL clock. A PLL clock can be used as clock source. For more information, why should I? I want the least divider possible. Okay, let's check if we can, what we can achieve, the highest clock rate here. Maybe we can achieve even more, but I doubt it, because the let's check what happens. Okay, so this is illegal already. Wait, which did we change? This one here. Not legal. Yes. Apparently it seems to be, but I don't know. 240. I need 40. I need 40 megahertz. But this is not legal. This should be 2. But it works, still works. Clock select, diff number. What happens if we, this is also 2. This is the same as 2, I think, from what I saw. So I'm wondering, where is the dividing coming from? Okay, 160, and then we divide by 2, and no, it doesn't do anything. What? Yeah, but we have only one divider. This is none. This is 2. And this obviously, TX back diff, this one here, is 1 now. Otherwise we have, so there is this factor where we did this divider that we can see. So it's actually like 80 megahertz or something. I don't know. It's strange. Does it do anything right now? Yeah. So this is now, this clock now is 20 megahertz. If we configure it like it's legal. Okay, so actually we can do this. Can we read with this clock as well? Zero 0.5. Okay, so we can use 40 megahertz. We can check if the APLL clock has different capabilities. I've used APLL for VGA and PAL. Where is it? APLL clock. Conf. APLL. Okay, we can use I2S, SADAC, section here. Okay, so this is okay, so the frequency of the crystal oscillator usually 40 megahertz. So we can use SDM and then the divider. So operating frequency of the numerator so this is like 350 to 500 megahertz. This is the operating range. So it's divided by 4. So if you have like, we can generate that up to like 100 megahertz. If ODIF, what is ODIF? 0 between 0 and 31. So we have here, wait, you can see, we have here divided by 4. And this will be this term will be like 400 megahertz. But if something similar happens, if we get like 400, stable 400, okay, whatever. We don't need that. We have our 40 megahertz. Let's keep on track, okay? So we are able to write like a loop. Let me check off one checkbox here. So we can write a block, we can write a loop. This is all right. Now, can we read something? Okay, can we read a block? Or can we read an infinite block? Famous last words. Words. Okay, features. Master slave receiving mode, data transmission. Or should we try the slave mode directly? Receiving data. RX mode, transmitting mode, master, camera slave receiving mode. This is the sequence, okay? So I've put this to the code already. We don't need that anymore. We have a working I don't need other implementations. My implementations is worky. Okay, here, this is the old one. We need this as reference. Okay, so we have this loop here. We have the pins. We have this here. Let's read block parallel master. Read block parallel master. Okay, so this is data. We have the pins, 8-bit. I forgot what this was. One. What's that? Oh yeah, that's the size is determined by the DMA. We don't need that. We can remove this easily from our code. Samples. We don't need samples here, and we don't need samples here. Okay. Read. Okay, I moved that a little bit. Okay, here we go. Simple code to read I2S. This is what we try to do right now. Okay, and the signal generation and so on we will do right after we have it implemented. Okay, no worries. Here we go. Data pins. Yeah. So we have that. And this is basically all the comments already. So we have enable, configure clock, blah, 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 blah. Okay. So illegal. Configure signal pins according to table, blah, blah, blah. We can use that, and this is basically, oh yeah, we need this new implementation because I changed that. Configure. Okay, and we need to do GPIO matrix out. Wait. Oh yeah, we will do something similar. Physical. How? Wait, signal generator. Input of the I2S. I don't get this. How? Simple code to read I2S. Yeah, we are sure that it's 40 megahertz right now. I don't know. I mean, simple is not simple. How do you write a simple code that runs at 40 megahertz? Why is this in? How does this work? This should be out. Oh wait, I2S out. Yeah, just how? How check the timings? How? Tell me how. I mean, we see that on the oscilloscope. This is 40 megahertz. This is the timing. We checked it with the FFT, and at 40 megahertz we have a peak. So, or at least this is how we can. This is the bandwidth that we can output a word on. This is like the frequency that we can output a word on the I2S. Okay. Okay. I2S 0. What is this output? Heh. Okay, I need to analyze this. This is hard to. Wait, I2S. Reset FIFO. Boop, 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 boop. Input. I have no clue which signal. Yeah, I need to find out which signal is the right one. In, out. Input signals, output signals. 0. Word select output. O. I have no clue. What is it? Word select out. Input, word select, output. I input. So input, word select, out. And this is input data. Wait, what? Input data input. Man. Input data in, but there are only 16. Okay. See you later. There are only 16 signals. Input. Output data output. Wait. Input. Okay, this is what we got. I hope this is right. I'm sorry. Okay. So we configured the clock. Oh, this is the clock. This is RX. RX. Let's start with, thanks. Let's start with legal stuff, okay? Not legal. One, not legal, but cool. Thank you. Okay, so this is the matrix. Set the bit LCD enable in register. Wait, this is the wrong code. What am I changing here? Right block. Oh no! I'm changing my working code. Oh no! Oh no! Okay, here we go. Here we go. Boom. Ah yeah. This is also, I should use my my definition here. Okay. So this is out in, and this is, I hope I didn't break it. Okay. Right, and this is now read. Okay, so Rx, then okay, conf2 LCD enable in the rack here. So we have similar stuff. Do we need camera enable? let's do Rx. Let's leave it like that. So we want master. We don't want slave. So we don't want the camera. We can use camera. I don't mind having camera, like they say. Okay. Okay. Camera enable. No, wait. We can't use camera enable in the master. We just use that. Okay. Then we need set the bit Rx DMA equal, then configure Rx bits mode. Gen mode, write first, format, okay? Bits mode, we had that here, everything. This is basically the same. Where is the bits mode? Big endian. Oh, what the F? This is, oh, this is why it didn't work, huh? Zero. That might be a source of crashes. Bits. Okay, here we have Rx bits mode, but this should be TX also. TX bits mod. TX big endian. Rx big endian, Rx MS most significant. Okay. MSB SB mod Rx John mod. What is right first? Okay, let's check this out. Let's search for this string. And according to section, whatever. Ah. Yeah. I'm lost with this code. Only ever use master slave. Oh, I don't trust Copilot enough to have this done today. I don't know how often a Copilot saw code like that. Oh, where is the child mode? Rx bit mode mod. Data in memory. Oh, really? So they trained it on me, and now they want money for my data. Okay, right first doesn't matter because we don't have stereo. What is the Chan mod? Most significant bit, mods, MSB modes. Where is the? What the mono modes? RxD DMA equal 1. This is so confusing. Mono mode. I have no clue. Dual channel. I have no clue what this is. Receiving, whatever. DM equal. It's basically, yeah, whatever. Slave. Let's just try to not understand everything. Mod, Chan mod, right first, 0, everything 0. But this bits mod, it's like, what did I do? Oh yeah, that's the bits count, big endian MSB. I think that doesn't matter because we only have mono anyways. Set the bits, descriptor enable, FIFO conf register, okay, it's descriptor enable. We did this here. Okay. Descriptor reset Rx unit in FIFO according blah blah blah. Okay, reset Rx unit. We did this here. And it's FIFO, so this is Rx, 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 Rx. Then set and clear it, com sync, FIFO reset. Yeah, we don't have com sync. But we can still reset it. Where is the com sync? So, come sync FIFO reset is conf2. So this is conf2, conf2, rx. Now come sync FIFO, oops, for reset equals 1 and 0. Okay. Do we use the cam already? Yeah, we use everything, don't we? No. No, camera enable. Okay, we don't need that for now. Enable interrupt as described. We don't want interrupts. 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 No interrupts for now. Set the length of Rx data in the register to start DMA. Length of Rx data. Okay. There is no outlink start, I think. Rx. In okay, I need to check that one. Okay, the transmission data can be done in bursts. I never did a read with I2S. Oh, wait. Yeah, let's. How do we set this properly? How do we set this to infinite? And we want to. I mean, we can. If we have 40 megahertz, okay, let's just set anything here. I2S. Wow. Let me check. Yeah, okay. Yeah, this is like the head, the master. We can only use the stable, which changed a lot. Yeah, this is high level. I don't want to use the high level because then we can't mess around with like the clock and so on. There is no there is no what is this? There is no way, I think, to do an infinite loop there. Wait, can demo. No, there is not much about this. If the technical manual doesn't say, oops, no, how many, okay, let's set it to -1 and then see if we can, if it works with 0 as well to be infinite. Because I'm wondering, how do you queue multiple reads if you don't want to have a gap like of a few samples, if you're recording like audio and then your buffer is basically done, how do you continue? Hey, Bruxus. Okay, we need to set the RX start wait drift. RX start. Okay, so RX start. No, it's not audio. It's way more complicated. Yeah, you can check that out. System, just check if you can find anything on that. I mean, you can use interrupt to basically restart it, but you have like a few clock cycles gap. I think they just restart with the interrupt, which indicates that it's done. Okay, corresponding interrupt, blah, 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 blah. Okay, here we go. This should be giving us an output. Let's compile and see if what happens. Oh yeah, we don't have that anymore. Oh. What? What is the data in oh, this is 0, not 1. Okay. It is 0. What? What's the signal name? In data in S0, in data in IDX, in data in 16, 15 is the highest, okay? That's the problem. It starts at 0, okay. Oh yeah, here we go. RX MSB mod. RX MSB right. It is right. Chan mode, okay. So what I expect is to see the clock. I want to see Chan mode. What's the channel mode? Is the channel mode conf chan? Yeah, that's what I mean. Okay. Okay, let's start uploading. Oh yes. Okay, we got the clock. Okay. So we got a clock cycle here, which is trigger source 3. Okay, 20 megahertz clock. Okay, that works. So we got a 20 megahertz clock, but I have still the conservative divider. Now I will use the waveform generator waveform generator. Wait, where is it? Okay, here we go. To generate a signal. What do I do here? This is like, come on. No. I want, what do I want? I don't need that. I don't need that. This is trash. I need proper pins here. Okay. And I will basically add this here. Oh. I can use this as input. Wave gen, frequency is 40 kilohertz. Interesting. Yeah, whatever. Wait. Which one is this? Eh? Confusion. Amplitude, offset, kilohertz. Let me get a screwdriver. Okay. So what do I see here? Okay, so this is this is my waveform. Oops. And I should be, maybe I can increase that a little. Oops, I don't want negative. So this will be 1.6. And this will be also 1.6. Okay. I can increase the frequency even more. So we have, okay. So This is the limit, 20 megahertz. You don't see anything? Okay, here we go. Now we should be reading this signal, okay? I will use it as input. Here. We should see some random samples. I will try to read the samples from the buffer, like the first sample, and see what's happening there, okay? Oh, they're defined as output. That's not good. We have a problem. We have the pins defined as output, I think. Mode input, no. Yeah. Here we go. These are input, this is output. Okay, small mistake on my side. I just shorted the waveform generator with... Oh yeah, there is only one, since output enable isn't invertible. Okay, nice. Let's see if destroying. No, okay. Now it's reading. And now we try to get a random sample in our main loop. Wait. If we can set the count of samples here. Let's calculate how many samples. We have 20 megahertz clock. So that's 20 million times seconds, okay? So let's do 20 million. Too many zeros. 20 million. That should be 10 seconds. Let's try that. See what happens. I'll crop a little bit. No. Oh, yeah. Okay, it should, after 10 seconds, it should be going off. Okay. I don't see it like quitting to record. Look at that. We are still the clock there. Oh, maybe the clock is always there. Okay. Let's see if we can read the data. We have data 1. Yeah, that's what I'm doing right now. I'm outputting the data, the boof of the data. Where's the boof? Here. Boof. Data, oops, boof 0, basically. I will always print the first sample and see if it's changing, okay? It might be a boot loop because accessing the same memory as the DMA. Wait, what? Not accessible? Oh, fool. No worries. Okay. No. It's not reading anything. Oh, we can check, we can clear. We can initialize the data with 0. And see what we get as output there. Okay. If we would read anything, we would see it there. So apparently, let me check if we get the clock even though we didn't start. Okay, so no RX start here. Interesting. Okay. So it started, but it doesn't write to the buffer. So we have to change the ownership. Okay, ownership is 1. Let's check. Okay. Let's try ownership 0. I need to be careful. Features, linked list, owner. The DMA can access the buffer now. Ownership, it's not a problem, the ownership. The ownership is not a problem. RX FIFO mode, wait. We have certain things here they might want to try. Data none. FIFO mode force enable, descriptor enable, value. Oh, if it's only supported by camera. Yeah, I can try that. You know what? If it only supports reading, if we get like some kind of signal. Yeah, but I didn't activate camera mode. So, and we can use as sync, we can basically use, so if you can, okay. You can also, like, I can Google as well. Okay, here is something, generic parallel input. Okay. Okay, I found some info here, which basically is my topic, but let's check that first. So let's do 4. I don't get. No. Okay. Maybe now. 0. That's not the issue. Okay, let's see. Enabling the S module clock. This may be been done in other project, but I didn't see it. Toggling vsync. The ESP projects all tied the value high and relied on the pixel clock working from me. The biggest issue I'm having now is cannot configure 8-bit word. You're working as expected. Any case, here's my code. Assesses it right now, copying here. Anyone in the future chance of have some feedback. Edit code remove, see later post this thread, update version. But data ingest starts with index. Yeah, that's up to spec. Okay. In duplicate, I'm outputting a bit clock from function generator data line that's of square waves. Blah blah. Oh wow. Okay. Let's clone that code. Let's fork the code. App main struct input manager init. Okay. Yeah, this let's see. Oh, so low speed modes. Okay, here we go. No, I just need this part here to check what I am missing in my code. I mean, it starts, but I don't see any changes. Maybe I'm reading the wrong signal or something. Okay, let me clone that. Oh, come on. What source input? Yeah, this is pin 0. I mean pin 1. I could be. I can use a different signal. Let me check that. Okay. Everything all right with that. Oh, I don't need to. Headers won't be compiled. Okay, on their own. All right. What I can try is to get the input high, basically. As pin. Oh, wait. Matrix in. Okay. So this we can also use. Where is that? Nope, nope, nope. Ah, come on. What? Searching, okay. You search for what? Come on. We had this here. Okay, let me check. GPIO RTC. What? What is this? What is this line? What am I looking at? Huh? What? This doesn't have the documentation for that? Okay, set signal output. But this is ESP. In FIFO debug that remains TMR FIFO data. Okay, I will check that. Let me just check if I can find GPIO. Okay, I can set this to 38. Okay, like that, to high. So we basically oops. We basically write once everywhere. Okay, so this is my trick for today. Every input pin will be set to high in the matrix. So it should write, if it's writing, if it's writing to memory, we should be able to see. No, it's not writing. Look at this. All the signals are zero. Wait. Okay, let me define more pins. Sixteen. Okay. Okay, still zero. Okay, so let's check now what's missing. If we don't get stuff written to, I could remove that already again. Sometimes it works, sometimes it doesn't. So if with the, you need to use CDC on boot enabled, that would usually, if the ESP doesn't crash, you can still reprogram it. So in my case, it doesn't crash, so I can reprogram it, but sometimes it loses basically the CDC, so that doesn't work either. Okay. Oh, you need to, in Arduino, here, this is a flag, but you need to be in dev module. Like S2 dev module. Or, oh, wait. Which ESP32 do you have? I'm using the S2 or S3 or C3 would work because they have like built-in USB. But usually you can do this even better with the regular one with a separate serial chip. You don't have CDC on old ESP. Okay. Okay, so RX. Read. So this is the lcconf in reset. FIFO lccon. I don't see that. lcconf out loop test. But I don't see this here in reset. FIFO reset, RX reset. This is what we do. Oh, I have maybe... slave mode on. Wait. No, RX slave mode is off. Okay, let's do that one. Okay, they do cam clock loopback. Use hsync, vsync, href to control sampling. Use master loopback. Equivalent to setting pixel clock pin is an input and routing via GPIO matrix in. Okay. Let's do this reset. Where's our matrix camera enable? Okay. MSB, right shift, mono, sync, DM equal 1. So, right first, we need that one. That is DMA equal. So we have left and right same. No delays and timing sequences. Yeah, usually on reset we have that reset. We don't need to do this, but we might want to do this later. So I will just put it in here to get us reminded. Eric's Chan mods. That's the one. Okay. Descriptor owner, size, length. Number of bytes written to the buffer. That might be the issue. It thinks the buffer is full. It only writes until the buffer is full, and then it's done. Wait, no, that can't be. Wait, no. Ah. Oops. Okay, let's see if we get anything out. But we didn't configure camera properly yet. Hello, Sion. Let me check. I will disable the camera cam clock. I will disable this because I think the issue might have been the DMA buffer that was filled already. Okay. Nope, still 0. That would be a coincidence. Oh wait, it's not like it's not possible. Let me check if we can. Yeah, let's do that. Oh, feeling a little bit tired already. Buff, 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 buff. I times 10. We have 1000 samples. How many samples do we have? 1000 samples. Okay, whatever. 50, whatever. Oh, we need spacer. Boop, boop. Nope. Look at this. No data whatsoever. Okay. Let's activate the loopback and enable, and then we need to maybe configure descriptor, and yeah, I have that already. This is pop, pop, pop. Let me check. Wait. Descriptor enable. I did that. Where is this? Descriptor enable. FIFO conf register. Yeah, I have this here. FIFO conf descriptor enable. Look at that. It's here. Now what I want to find in the documentation is, oh, that's the wrong one. How many documentations do we have open here? Yeah, I did that. I did that. I need to check what this loopback is. This bit loopback clock from VS out. Input, word select out. Cam clock. Okay, so 0 I2S out. Okay, this is what I configured. I2S out, IDX. This is what we see. So loopback is now on. We need, okay, camera is enabled now. Zero. Bye-bye. You know what we can output? We can output how many bytes were written from this here. Basically, print line length. If this changes, I know that it's working, okay? And one last thing, I think we need to do this sync. Yeah, this is the one. VSync. This is the magic. This is the magic that happens after the start. They start the frame. They just trigger the frame and set everything high. Oh, this is funny. Oh, I didn't yet. The GPIO matrix is able to do this, but it seems to, but I didn't do this yet. I'm currently doing the master. So I'm generating the clock, and basically the clock and the words select is same. Oh wait, yes. Is it though? Yes, because I'm writing the whole word at once. I'm confused now. If we have stereo, we might. I'm not sure. I will replace this now with high. This is all the high stuff. High, high, low. Okay, let's try that. Oh wait, we have a huge text block here. This is basically what. I should have read that what I copied before. Okay. Look at this. So the buffer is filled. Now let's check the contents of the buffer. we just needed the trigger with the GPIO matrix. That was missing. Oh yes, baby. Here we go. Oh. We have the block. Okay? We have the block. Ship it. Oh, funny. Oh, interesting. It really didn't matter if we have it written or not, because I disabled the loop check. You know, we have, okay, yeah, we have this here, which really doesn't matter, the set length, because it's rewriting. Look at this, it's rewriting the buffer over and over again. But when does it stop? Didn't we want just to write like a few bytes? Wait a second. Wait a minute. Who are you? Okay, let's read only 2000 words, okay? That shouldn't overwrite all the time. Hello, Christian. Yoo-hoo, it works. Nope. Okay, that's interesting. It doesn't stop. It doesn't stop if the buffer is the ring buffer. It's funny. Look at this. It's overwriting. Okay, let me use zero here. Okay, I assume it's ignored when ring buffer is so ring buffer is basically what we did here by saying next, next, and all the buffers are not end of file by next. Oh wait, does it even use that? Wait, next, 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 set buffer. Where's the elf? Do I clear it? That's strange. It seems like it doesn't even use its own flags. Yeah, let me see. Descriptor, where is my next function? Huh? Here. No. It's simply ignoring everything. Oh, wait. I think I need to restart. Uh-oh. Okay. No. Yeah, it's reading like infinite. Wait. Why is only the first byte changed? Let me change that here. I want to see which bytes are written or not. Oh, interesting. Look at that. This is only like 1 byte is written. Wait. So That's not true what I have written there. It reads only 1 byte. Here. 1 byte. If I do 10, let's check this. ESP32 S, okay, yeah, might be. CDC upload is quite quick, huh? And yeah, basically, if I don't use any libraries, only registers, there is not much to compile either. Reset this. Oh, look at that. That works. What if I when I do 1000? I need to check what's happening with that. If so, that flag works, but at some point it doesn't. Nope. Okay. It fills both buffers. When I give it like a length, or does it only like fill the buffer, each buffer until this length? I need to check, because I don't really know what this thing means right now. Oh, look at that. It fills every buffer in the chain. This is not the total length. This is basically the number of bytes per buffer. Okay. So if we give it like the maximum, this will be always oh, that's the count of words also. Oh. I might crash. Oh, we need to check some boxes here. We are able to read the block. Hmm. ESP32 S is almost free. Yeah, I stick to the S2 because of the built-in USB. Way easier design. Yeah, what did I do? I'm really happy that we came so far already. Okay. Let me think. Okay, output. Sorry, monitor. What is happening? Oh, wait. It writes the bytes that I give it and then continues with the next buffer. Oh, this is crazy. Okay. Okay, we know what happens now, okay? Okay, so count of words written all buffers then triggers but continues with next buffer in chain. Okay, so this is what happens. So we can do -1 to get the most out of it. Install coffee and noms. No coffee at this time. Are you crazy? Okay, monitor. Yeah, the CDC is a little bit buggy sometimes. I don't know. This is okay. So this will record forever until I tell it to stop. Probably. Okay, let's calculate how much record. How long we can record with that. Okay, let's say we do 40 megahertz. And we can do 4 billion. So 4 billion is basically 100 seconds. What? We can record for 100 seconds continuously before it loops over. Oh, that might be right. Oh no, yeah, you are right. My phone died. Not that there was like, oh wait, and also my battery dies on the microphone. Wait. Back. Okay, I'm back. 0%. Okay. So that's that. This is the trigger. Okay, let's read what we have here. Okay. Now the next part is we disable this here. And then we check output. Okay. We see some data written. Now we increase the frequency, okay? Let's do 2 and see if that works. Battery crisis. On all-nighter engaged? No, we have 20 minutes. No. I think this will be easy. Easy going. What is this bug here? Some fly. Okay, serial monitor. Still worky. Now let's try the illegal one. Okay, I can start my phone now. Oh. Oh, wow. What's happening? Do you see the clock? What is that? This is like a perfectly stable 40 megahertz clock. Wow. Okay, now let's check if we get any readings though. Okay. I need to restart it. It's a little bit buggy this. Oh yeah, we still get readings. I don't know if this is like a legal signal or not. Illegal. Okay, nice. Okay, so we have 40 megahertz read now. Now we need to combine. Oh yeah, we need to combine the two things. This one here and wait, and RMT, and try. Okay. Combine the power rings. Okay, this is like, oh yeah. We need to copy all this trash here over to this one here because I like that. And this here comes here. And this is not needed anymore. Okay, and this is not needed anymore. And this is not needed anymore. And this is not needed anymore. This is basically everything. I don't need this. I don't need that. I don't need, oh yeah, this is the LED. This is okay. I don't need that. Watchdog. I don't need read bits anymore, and I don't need cycles. Yeah, let's kick this. Kick everything. I don't need that. I don't need that. I don't need that. Can't hear you. What? Wait, I'm joining. Sorry. What didn't I hear? Are we there yet? Hey, Mr. Johnny. Okay. You have so many monitors here, so many screens. You wouldn't believe it. Okay, that looks like a little bit cleaner right now. Let me compile and see that's still working. And then, wait, what's what? Oh, what did I fix? Yeah, we have read. Wait, what's happening here? Ah. Oh yeah, here the scripter. Let me check. This is. Oh, what did you miss though? Okay, so there is one trick. This is apart from the technical documentation. I had it there, but what this example code did is basically triggering the vsync. And that's what needs to be done for the parallel input mode to work. And then we have also like a stable 40 megahertz read there. So I have, yeah, this is the input basically, and it changes all the time, reading like 2 times 1000 bytes. And now we are combining both, the best of both worlds here. So RMT, which is this here, this here, yeah. Okay, I don't need that crap, and I don't need that crap, and I don't need that crap. And this is init RMT. This is init RMT. And then we need pin clock is basically what we need as input. This will be word select and clock. A little bit late, isn't it? Read parallel master, and then now let's do slave now. Parallel slave. Slave. Okay. Okay, clock pin in IDX false. How about that? Clock pin. Do we need another clock pin? And we need to clock. So what's the clock name? Wait, I will just do camera slave receiving mode. Okay. Pop, pop, pop. We don't need a different one. We don't need a clock. Okay, no clock then. Slave mode, yes. And that's basically it. I hope you don't trash anything here. I need we have this clock, but I need this one here, and I need some. Yes, it is. Yeah, we need this input here. Oh shit. Okay, do we even get any? Oh wow, we even getting like floating inputs, do we? No, this is like, oh wow, interesting. Okay. Now, should we try to read the analog signal then? I'm confused. Wait. Let's try. Wait. Okay. Okay. I'm confused now. So many things to do at once. Okay. So we might actually get some readings now from the analog, digital to analog converter, and I need to connect it. Right. Okay. We are reading values. Nobody knows what these values mean. This is floating. Okay, so let's do a no floating signal. I need this. Okay, so this is an output, and I need also ground. This will be, what is this? Hey. I have no clue what I'm doing here. Okay. Maybe we need this ground here. Is this ground? Wait. Yeah. Okay. We need this ground at this speed. Now, what is this? Yeah, it might be a good idea. 20 megahertz. Let me remove that. And the trigger would be source 2. This is looking more and more like a mad scientist experiment, like some random wibbly wobbly waveforms and some outputs. Like this looks like the Matrix. Okay, so let's change the clock. The clock divider here. Clock divider 4. Okay. Still 40 megahertz. What? Huh? Uh-oh. Why is this still 40 megahertz? Why is this 40 megahertz? I wanted it to be not 40 megahertz. Wait, config 2. No, I think this is like strange stuff. Stranger things going on here. Yeah. This shape doesn't work with this divider. If I do like divider 10 or 8, it wouldn't change anything because this remote control stuff is weird. Yeah. Okay. Then let me do this like that. 4. Let me check that. Hey? Is this overwriting? Is this clock still overwriting? Wait, I don't want a loop back. Loop back. This is what we don't want. Hey, it's uploading a lot of stuff. Huh? Why? What's happening here? Why is this clock? I mean, I could work with that, but I wanted a slave mode here. Nope. It has nothing to do with that clock here. Let me disable this. Where is this clock coming from? I'm not setting any clock to 40 megahertz. It's still there. Okay, this is not my clock. Where's this clock coming from? Do we still get like samples? This is not a slave mode. Yeah, we're still receiving samples here. What is this clock? What is this 40 megahertz clock? Oh wait, slave. Everything. Yes, this is for the phased arrays. Yes, it is. Here we go. This was the issue. Okay. I was using the wrong code all the time. All our tests are meaningless. Oh, there will be many parts. So first of all, we need new hardware, and this is basically part of that. This is like step 1 of 3 or something of new hardware and new approach. We need high-speed ADC inputs and many ADCs at the same time. Okay, this is not. Okay, I need to do that. Seems to be brokener. Brokenered. Oh, we have midnight already. Oh, thanks. Okay. Oh, wait, what? Oh. Oh, I might be disabling the output. Do I read it though? No. I don't read any bytes anymore. We might need to do the following. Whoops, this is the wrong file. I'm looking for, okay. So slave, where's loopback? There. Let me check if that does the trick. But I need to, on this input, disable the pull mode here and direction inputs. So basically just this here. Instead of this. Okay, that is as expected. Oh. Oh, that should be in. False. Wait, do I change a different code again? I'm changing again code that I shouldn't. Yeah. Okay, this, but what was this? Read block. Yeah, this is also in. No, out. That's all right. Okay. Oh yes, mwah. We got the output again. And we get the readings. Nice. Okay. Next step. I want a slight change. I will be how do I do this? How many cycles do I use here? Okay, so reading slave works as well. I don't know if we do any meaningful stuff, but reading and slave mode works. Okay, now use sync signals. Oh shoot, that's yeah. Yeah, not only there, 5G and like new Wi-Fi standards all use phased arrays. This is really crazy. Okay, here we go. Let's do a divider by 4 so we have a more stable. Do you think? What? Next week's video? You mean next week's stream? No. I finished this week, edit. Oh, I have only 1 day time. Shoot. I need to get my editor. I requested some today. Either this or I just record yeah, editor maybe. I asked 2 guys to help me with editing. I will pay them, of course. So at least I think I can get some more time to finish the projects. Louis, do you want to be editor for bitluni's lab? I will pay you the same as I pay pay the other guys from Fiverr. Sniff is interested? Yeah, I don't think Sniff is interested that much that he would do this consistent forever. Yeah, you need to use resolve. You need to get proficient in resolve. So we can talk about this, but obviously, like British, our hourly rates are different from South Africans or Indian or I use Resolve. Yeah, many things changed in Resolve. Job loony. Yeah, we can talk about this. No worries. But I think you are so busy. You're doing so much stuff. I don't know if you will be able to like maintain that. But you can try. Certainly, I can give you some project to edit. Do you have good color vision? Because I don't need another one like me. Okay. So for the syncing, I will do a trick. Yeah, no, I have like 2 people now contacted already, which would do the job, and they take like, this is, okay, on Fiverr they take like below $100 per video. That's about like 10 minutes long or something. I don't know what that contains, but I can imagine that I cannot expect that amount of effort that I put in editing from a 100 euros or dollars rate or something. So this is, I don't know. I mean, if I can output, like increase my output of videos and I get like my sponsorships here and there from the videos. So each video, like for 20,000 views, I get at least from Google $100. So that would pay for itself. And then on top of that, I get a lot, like much more for the sponsorships. So I can pay a person from that. And so if the turnover increases a lot more, there is also a lot more of that I would happily pay a person to edit videos for me. It's just a matter of scaling, I think. So the problem is like teaching a person. So since like a pro would take a lot more of money and will be probably not stay around for a long time. It's an investment to teach someone like the style and the workflow and set everything up and then get everything like going. That's like an initial investment of time and money and effort, and then yeah, I don't know. Let's see what happens. RRB and GGB LEDs. Yeah, that's true. These rotating antennas on boats, these should be phased arrays. Okay. Or at least it's just like it concentrates like the signal, so you have an array. It's not like shifting the phase actively. It's just canceling other stuff. Okay, let's finish this. So one trick that I want to use is basically now record every sample, including the signal there. So I will just kill 1 byte of these here and set the input signal thing. Where is it? 16. Wait. Wait, this is wrong file again. Oh, I'm getting tired. Yeah. Okay, so I can basically start this and then set the signal will be and we can use basically this signal, we can replace it with the pin for the word select. Wait, chip select, no, yeah, it's chip select. So we sacrifice 1 bit of the input to get the bytes synced. How do I output base 2? Is this like that? And then I will deserialize it. Okay, here we go. What is this? What is this madness? The first one is 0 all the time. That doesn't help. That doesn't help because it has no leading zeros. Okay. Let's do it like that. The last bit should always be 0 except if the signal is not valid. Yeah, you know what? So Lewis, he goes to university. He's coding. He's recompiling kernels, and he has so many interests. So Lewis has so many interests, like more coding, developing, playing with machine learning. I don't think that Lewis is passionate about editing his whole life. I mean, I don't say what you have to do or not do, but I think you will be bored like in 1 week doing that. Networking. Good night, tech. Somehow the first byte is always 0. This is like suspicious data. Wait, we increase, okay. Okay, let's display 32 values. Oh, really? Okay. Network engineering. Okay, maybe you, you will be editor after all. Okay, this is the matrix. Is anyone seeing anything there? It's lots of bits and bobs and blips and blobs. I don't see the high bit anywhere. Yeah, there is no high bit somehow. Poor Sniff. It's being pushed around today. Where did I put this? Wait, RMT here. I don't see a single. Okay, now the signal would be there. Foo. Maybe the clock rate is still too high. Let's try a way slower clock. It's still looking like strange. Pin chip select, that doesn't work. I don't know why. Nope. Okay, if okay, only that. Let's see if we get any reading. No, because these are serialized. That doesn't work yet. I need to find the edge. No, we don't get a single data point with. So reading back the chip select doesn't work. No, that's the frequency reading is perfect. I only need that one here. Okay, let me change the waveform to something like 1 megahertz. Or maybe not. How can we use the GPIO matrix in to get this? I need to connect the chip select to, so I generate the chip select and I want to use it as one pin. So I have like this, I'm also already using it as clock source, but I also want to store it in one of the bits in the parallel input. So what you see up there, like the highest signal, I want to know like which bit I'm looking at. So I want to store this signal as well. And this is this is hard. It seems not to be working. Okay, one thing that I didn't try is using this before I start the transmission. So this is read slave and store chip select in. Yeah, and I don't know how that works. It worked with the other signal, with the clock signals already for the sync, but okay, I need pin clock select, which is 26. Oh, yeah, that's basically. It's basically the same. No, it's not. This is the word. Yeah. Clock. Yeah. I doubt that I can handle 40 million interrupts a second. So the problem is with the counter, what happens? What happens? So how do you synchronize that? Yeah. That's what I think. Yeah, that doesn't work. I don't know why, but it doesn't work. Shoot. Can I use 26 here? That's interesting. Let me check if I can use it as a regular clock signal. Yeah, I can. That works. Wait. Maybe I'm recording. No, I should see a signal at some point. Okay. Let me try in 8IDX. If we see odd and even numbers. Yeah, there's no odd number. This doesn't work. I don't know why. Maybe we are recording at the wrong time. Let me check that. Okay, let me try that. Not clock pin, 26. Okay. It looks like I can't get this signal into one of the data bits. I would need to, you know what I need? I will try something different. I will try, which one is it? Okay, this one here. I will try to put this back in pin 9 or 10. Yeah, that's what I'm doing right now. I'm just using another pin for that. This is basically I will try. Oops. Okay. It might be 10 or 9. I don't know. One of these pins is this. Yeah, I think it's 10. I can basically switch. Oh yeah, I see. Rarely. Oh no, that doesn't make sense at all. What I see there. Foo. Let's try again. Okay, is this a random pattern? Okay, this is floating. Yeah, no, this isn't 10. Okay. No. That does not look meaningful. Oh no. I would expect this to see a pattern there. I don't see a pattern, really. No, that's basically random. Yeah, I have like only 1 megahertz now. This is already quite low. I think I'm done. I'm so tired already. That won't help today, unfortunately. Oh, I don't know if I have an idea how to do this. Why don't get a reading from that, a proper reading? Okay, I can try another thing. I can try to read something now. I can't get the clock. We managed to do a lot of stuff today. I think this is good enough for today. Everyone, I'm tired. I will leave that as it is right now. Read slave. Yeah, that's not that's something that we need to prove if we are actually reading something or what that is. I'm not sure yet. And yeah, syncing will be very hard. It might be. It might not. I don't know. I have a few ideas what to do. Maybe we can try stuff. Reading the signal took like 2 hours, yeah. Okay. Everyone, thank you for joining the stream. It was a boring coding stream again. I hope you enjoyed at least looking at the oscilloscope with wibbly wobbly. Oh, Lewis, why are you still awake? Okay, it's not that late at your place. Oh, it's 12 o'clock for you as well. So that was a 5-hour stream. What? Okay. Enough for today. I see you next week. It's my birthday on next Wednesday. Okay. So, see you next week or Wednesday or Tuesday in the Hangouts. Bye bye. Where's the music? We need the music. I can't hear the music. I can only imagine the music. No, you don't do this. That's bad luck. No pre-happy birthday. Okay, bye bye. I can't find anything here. How do I turn this off? Ah! Oh, here you go. Oops. Oh no.